Thanks for having me on the EclipseCon 2021. The session is about Eclipse Dataspace Connector, how to build data spaces. And my name is Markus Spiekermann. I'm head of Department Data Business at the Fraunhofer Institute for Software and Systems Engineering, ISST, which is one of the ICT institutes of the Fraunhofer Society, as the biggest research organization for applied science in Europe. In addition, I'm the project lead of the newish Eclipse Foundation project, the Eclipse Dataspace Connector, that will be part of this session. And I really like to give you some insights within this session here. So I have brought a short agenda for this session, and I really would like to give you, first of all, an introduction and motivation about the topic. So how to build data spaces, but also why to build data spaces. Then I will get into the topic data spaces itself, try to give you a brief overview about the architecture and the idea behind this architectural pattern and what we want to achieve with data spaces. Then I will go over to the business ecosystems and networks as communities that adopt this approach of data spaces and bring this to production and really make business out of this approach. And then introduce the Eclipse Dataspace Connector and really show you what we address with the project and what challenges we are focusing on right now and implement in the Eclipse community. So first of all, it's all about the data economy. And of course, every one of you heard that data has value. This is especially true in this new data economy setup, where we have different organizations, different companies sharing data to drive their businesses, to drive their new products, extend maybe tangible products with digital services. And the challenge they are facing right now is that they have to share the data, but want to do that on a secure and sovereign way. So we call it sovereign as having control about what happens to your data, also if you maybe exchange it and give it to the hands of other organizations. And this is also addressed by politics and also addressed in different strategy papers, for example, from the European Union, but also from the German or French governments, where they have in their strategy papers a concept called data spaces what is about having architectures and infrastructures to share the data in such a sovereign way. So if we have a look on different scenarios regarding the exchange of data, you can see more or less three patterns. So first of all, there's this just bilateral data exchange where two partners just share data. So they align on what protocol they want to have. They know each other, so no identification is required. They just send a link or maybe just send an email with the file inside to exchange the data. Very easy scenario, I think. Then there's a second phase or scenario where we have a closed group that is exchanging data. So people or organization especially come together to share data for a specific use case in a specific domain maybe. And one of the partners do some kind of services for this group. So for example, there's identity management service, which provides all these identity services to the group. Everyone can use it. There's maybe a catalog that everyone is aware what kind of data sets are available in such a group. There could also be other services. But basically what is important to know here is that you have this one participant providing these kind of services like a platform for data sharing. And then there's this third scenario where we have this more like open and dynamic data exchange, where we don't have this kind of platform services at one participant, but these kind of services within a network that enables us to also onboard new partners in the network very fast, and also the decentralized exchange of all these partners. And this is what Dataspaces is about. And I would like to get some more words about Dataspaces and describe the architecture in showing you what a dataspace brings to the table right now and what kind of services we can use in building such dataspaces. So on the left-hand side, you see where a dataspace is located. So it is a layer between the infrastructure, what could be IoT services, for example, providing data, so sensor data as an example, and the service platforms that are machine learning applications, data science applications on top of the data. And what we need in the middle is exactly 2 points. This is there are services that manage cloud and edge layer. So for example, providing virtual machines, providing compute and other services on the infrastructure layer, and also services for data sharing. And the combination forms the data space that you and forms services that you can see here in the middle. Basically, you can divide it into essential services and basic services. What really is important here to mention are the essential services. One, we heard that in the different scenarios, is identity management. So very basic, essential service for a data space as well. You need to know to whom you're talking and with whom you're exchanging your data. Connectivity, of course, because there has to be interoperability. Every participant needs to connect with each other when we want to form this decentralized data space. For transparency reasons and so on, there has to be a logging. Every data exchange needs to be logged, that you are aware who's accessing your data and so on. There's cataloging as a service, so you can register your data sets, you can use it as a distribution channel, and all the other participants can have a look on what kind of data you're providing if you allow them to see this data in such a catalog. There's also the policy management, and this is very important because this is also addressed in 2 concrete initiatives I will show you in the next slides. That are describing this policy management in special, because it is important and also related to the need of action and the design principles in building such data spaces. Policies is more or less something we have to consider when talking about data spaces, because this brings the aspect of data sovereignty, trust, and security into it. If you see the design principles, so I mentioned European values, so these federation and federated architecture, that you have it secure and trusted, that you are vendor agnostic and so on. The need for action we have right now, and also in looking at this architecture, is how to build these essential services and provide these services with a good governance, with technologies. So how do we implement all these kind of services to really ensure transparency, ensure data sovereignty from end to end? So this need for action was derived on requirement engineering and so on, and firstly addressed by an initiative that was called International Dataspaces. So it was initiated in 2016. So this was more or less the starting point of this data sovereignty sorts in data spaces. And it was a combination of association with right now more than 130 members in 22 countries, and also a research project to have a combination on practical use case, and also the research on the other side to implement things and try really to create something that can be then used and in an iterative way. So basically, what are the objectives? So objectives are that the IDS creates a reference architecture for the data space. So remember the picture I showed you. So it describes and specifies how to build this architecture, how to implement the different services that are required, and give an overview for developers to get hands-on and really implement something. And this as a standard. So basically the IDS aims on building and creating a standard that then can be used for these data spaces. On the right, make a comparison between the essential services that are identified for data spaces and components that are named in this reference architecture model, currently in version 3, with an iterational update. You can see that for every of this essential service, or at least every essential service, there's a component available that is described and specified. For example, identity management with the dynamic attribution provisioning service, or with the cataloging with the IDS broker. This addresses the data sharing layer. The cloud and edge layer is addressed by the GAIAX European Association for Data and Cloud ISBL as one of the big European projects and initiatives that aims on building as well a standard for data spaces and having a sovereign infrastructure for data sharing with comparable but not the same objectives. So GAIAX really aims on describing policies and rules. So on the governance side, how different participants can act together in the data space and how they can work together and share their data. There's an architecture of standards. So not another standard should be provided by GAIAX, but there should be a way how different standards can be brought together and can be made interoperable. But then also specifications of federated services is one additional objective of GAIA-X. And this is also related to the essential services, adding different perspectives. So there are different perspectives between GAIA-X and IDS. And I also mentioned here on the right what kind of components can be compared to the essential services from this initiative. Okay, so basically this is what the data space is and initiatives that aiming on have these architecture models and try to implement components. But what is important is that we need someone to use these components and bring it to life, so to say. And this is done in different business ecosystems and networks. Business ecosystems and networks more or less can be seen as clusters. So different organizations come together, but not on a specific use case, but more on a broader part. So for example, a specific domain can be seen as an ecosystem. This could be mobility as an example. This could be maritime. This could be agriculture or energy, all the domains that you might think of. Another important topic is that it's not just the companies within this domain, but also bring them together with service providers and operating companies that then can handle the technical infrastructure and components of such a data space. It should enable collaboration, so they have to align on different business models. They want to drive the future of such an ecosystem. They want to address innovation and new products. They want to define common governance rules with democratic structures. And they are open for new participants and also technologies. And two initiatives that fit into this more or less definition of business ecosystems now start using also the concept of data spaces, and that's why I want to get into a description of these initiatives. So just as a wrap up, so we have the data spaces, we have initiatives forming a standard and an architecture, components that can be used, reference implementations maybe of the different components. And now we have the business side that wants to make use of these kind of concepts and components. And for example, there's the mobility data space. The mobility data space is initiated by German federal governments. So it was initiated in 2019. And the objective of the mobility data space is really create a data sharing community and form the future of next mobility services and also business models. They want to adopt the international data space reference architecture model and focus on or want to focus on implementations that are available on open source. It is an initiative that has more than 200 stakeholders, especially in Germany. So also from different domains, so government, but also enterprises, research partners, also small and medium enterprises, and so on. And they define different use cases, focusing more or less on smaller cases. Extending an existing service for recommending what kind of vehicle you should take if you have a day in, I don't know, Berlin or something like that, and want to see do some sightseeing here, and use external data to really improve your service. Just as an example, there are more than 20, and the interesting point here is that they are presented last week on the ITS World Congress. So basically, this is a big congress in Hamburg, which is going on, and there this mobility data spaces is presented, and all the use cases there as well. Currently, the phase of this mobility data space is to set up and onboard the different partners, and then be productive early 2022. There you see an overview of the different partners, all connected not to the platform, but to the essential services of such a data space. And then, as a second example, there's the Catena-X Automotive Network. The Catena-X Automotive Network is relatively new. It was founded in May 2021. It's an alliance, also addressing the different challenges in data sharing and business innovation within the automotive domain, and aims on forming a Gaia-X compliant IDS system. So really bring these two standards I mentioned together, and take these as an infrastructure layer for providing a network, a data space where different data sets can be shared for specific and different use cases. So for example, some are mentioned here. So different layers also in Catena-X Automotive Network. You see the Gaia-X compliant IDS system as the basis. And then on top, different business services that then can make use out of this data and have services like the CO2 calculator. There could also be a marketplace. There could business applications like the part chain, a data sharing, or this footprint use case. Yeah, so basically these are business ecosystems that are using data space technologies, standards. But that leads to another challenge, and this is that organizations are involved in different initiatives maybe these initiatives use different approaches and idea of having essential services, different components, different identity systems, for example. And the big challenge is how to bring this kind of federations and data spaces together. And this is where, we see a big challenge. So it shows we have to connect multiple data spaces. We have to support different transfer protocols. So of course, every data space could have other requirements for sharing the data. Identity is across in multiple ways. The catalog could be handled in multiple ways. Policy management, so the data sharing and data sovereignty aspect completely traverse and can be handled in multiple ways. So we need something that is extensible and modular to really have a component available that can facilitate all these different requirements. And this is what the Eclipse Dataspace Connector is about. The Eclipse Dataspace Connector is a project initialized in June and become an official project in June within the Eclipse Foundation, with aiming to develop a connector component that is also addressed in the different reference architectures, but in an extensible way, so that it is possible to support the one standard, but also the others by providing the possibility to write your own extensions or write extensions to specific reference architectures. You see here the committer teams, so various companies are involved. So Fraunhofer, SAP, BMW, Daimler, Amazon AWS, Deutsche Telekom, ZF Friedrichshafen, and Microsoft as an example, but there are also other companies involved that do not have a committer right now. But what we want to achieve in our community is really to have a connector with the following features. So we want to have it based on a simple modularity system. We want to separate control plane and data plane because this is very important to address this extensibility topic and really support different protocols. Of course, we want to be asynchronous. We want to be fully auditable and cloud aware. And not only be cloud aware, but also have this policy management cloud aware and address different layers of the infrastructure to enable this data sovereignty. So to visualize that, so see the connector as a coordinator. Basically, you have the custom runtime as the specific core, and then you can extend this runtime with specific modules. For example, the cataloging handled by external systems like Apache Atlas or catalog that you are using in your organization. The data transfer then is performed out of band. Like I said, it's important to support different protocols and also be modular here again. Processes modeled persistent state machines. So this way we really have a transparent process here, can log something, enable data sovereignty. We can provide foundation for full observability and data audit. This is because metadata is collected for each state and so on. To have one slide for the Cloudaware policy enforcement. So what you see here, the policy engine is Cloudaware. It's not limited to the connector. We can also enable horizontal and vertical enforcement here. As you see on the right, so it depends what kind of policies we get from other systems like IDS policies or ODRL policies. We want to have this policy model in the connector, be aware and then let it facilitate internally and communicate with extensions like OPA that then can handle the policies also in an internal in the internal infrastructure. So what is the status quo? The status quo is there that we have the GitHub repository up and running. We have the initial contribution that has been made. We have the data exchange up and running and the connectivity, and now merging IDS protocols. And also there's a YouTube channel available where you can see the onboarding experience to get more insights as well. So yeah, this as the last slide where you can get more information. So thank you and have fun on the other sessions as well. And I really would like to have a Q&A session right now. Yeah, so after having this short introduction to data spaces, architectures, use cases, and initiatives that are handling these kind of thinking in data spaces, are there any questions from the audience? So I saw there were in the chat at least some questions related to concrete initiatives like the dataspace mobility that was then answered later on in the presentation. So feel free to ask more questions. So there's one. So can you give a concrete example of what can actually be done with such a data space? So at least it's a network to share data with this aspect of data sovereignty. So it acts. Sorry. This acts like contracting and this policy negotiation and policy management topic to the direct data exchange. So if you want to drill it down, it's all about having an open ecosystem to share your data, but really have this kind of new aspects that we need to build trust also to share the data with externals to have such things in place. Okay, and then there's another question. So what is the role of open source in the data spaces? So basically, I think this is very important to have a close relation between open source and the data spaces, because what you see is, so we want to build trust, and we really want to be open, work together, and data spaces can also be compared with such kind with a kind of community. And this is also what drives open source. So yeah, it's definitely a thing. The people should join and really drive the implementation of such components that can be used in data spaces for the data experience in a community way. So basically, yeah, I would like to answer this as how to relate open source and these data spaces. Okay, then there is another question in the chat. So will there be a label of solutions like IDSA approved? So basically, this is something that is definitely happening right now and discussed. And this is part of the associations I mentioned earlier in the presentation. Basically, the IDS association, or also the Gaia-X ISBL, they are thinking like how to be, so what it means to be compliant with these kind of architectures and standards, and thinking about how to be certified or labeled to be IDS approved, so to say, like you named it in the chat. Okay, so there's just 1 minute left, but there's another question. So how do consumers of data find providers of data? So this is basically the catalog feature that I mentioned. So one of the essential services in such a data space that could also be decentralized and shared and synced in such a space. So many architecture options possible. But this is how people really find together. So demand and supply of data here. So we think of it as a marketplace, but not as a platform, maybe also maybe in as a decentral service. Okay, there's another question, but I think we are running out of time, unfortunately. Basically, what I like to add here is, so use collaboration possibilities of the EclipseCon, and also do not hesitate to reach out to me on LinkedIn or somewhere. You find me also on GitHub in the Eclipse Dataspace Connector project. We would really like to think things further with you together. So thanks.